Welcome. So we're continuing our journey in Chapter 4, which is looking at the savings and investment in the long term. So this is a particularly important chapter because, again, what we're going to be doing here is trying to understand the process of what determines long-term interest rates. Long-term interest rates are important because, again, as we'll see, a punchline of this chapter is that long-term interest rates are going to drive investment, which is going to drive growth. And so that's an important story in terms of thinking about what economies do and how they do them. Now, there's several twists to understanding the role of interest rates in the long run. And so because of that, we're actually going to look at this issue from two different standpoints. So not only are we concerned with what drives real interest rates in the long run, but we're also interested in what drives trade flows and capital flows in the long run. And so it turns out that those two things are sort of entangled together. And so because of that, because of the way in which they're interconnected, we have to look at it from the lens of a couple different models. So what we're going to do today in this video is look at this question of what's driving long-term interest rates. And in order to understand that, we have to make some simplifying assumptions. And so because of that, we're going to be looking at this question from a closed economy standpoint. So we're going to try to understand the role of changes in real interest rates and what drives real interest rates in the longer term by first understanding the basic underpinnings of a closed economy framework. Because of the fact that, as we'll see when we look at a small open economy, it turns out that a small open economy can allow us to understand trade flows, but doesn't really allow us to simply understand the mechanics of real interest rates. The flip side of that is with a closed economy framework, it's easy to understand the mechanics of changes in real interest rates and what drives long-term real interest rates. But by definition, with a closed economy, we don't really understand the mechanics behind what drives trade flows. And so there's a trade-off between simplicity and getting to these basic results. And so that's why we look at these two different models separately. And so with this model that we're going to be looking at here, the closed economy, again, as I talked about, the distinction here is that we want to understand what drives real interest rates. So to simplify the story, we're going to assume that net exports are equal to zero. And so by definition, this economy is closed. So we're going to simply be looking at spending on the consumption, investment, and government behavior side. And so we're precluding goods being able to come into the country as well as goods being able to be exported. But we'll simplify that. We'll open up and relax that assumption in a later video. And so what we'll see with this simple framework is that the implication is that a goods market equilibrium, which we'll talk about in a moment, implies that real interest rates are going to adjust in order to ensure a goods market equilibrium. Now, what we mean by a goods market equilibrium, and I'll talk about this over and over again, is that the amount of output produced is exactly what people in the economy want to buy. And so by people, what we're really talking about are the institutions of households, firms, and government. And so we produce a certain amount of output in this economy, and the question is, where do that output get allocated in the spending side? And it essentially gets allocated in, excuse me, essentially gets allocated in household spending, firm investment, and government spending. Again, we're abstracting from the net export sector. So in a goods market equilibrium, we're producing exactly what households, firms, and government want to buy, nothing more and nothing less. So that's what a goods market equilibrium means in this case. So in a closed economy, because of this goods market equilibrium and because of the way that we're setting this up, in a goods market equilibrium, if total output is equal to consumption plus investment plus government saving, plus government expenditures rather, then what that means is by definition, the amount of saving in the economy has got to be equal to investment. And we'll revisit this result here a little bit later on. So the important point to understand and underscore in terms of thinking about what a goods market equilibrium looks like is, first of all, what is saving? What does it look like, and what drives savings? And the flip side, excuse me, of what we'll see is thinking about what drives investment. When we put those things together, saving and investment, then in an equilibrium, the outcome is going to be, as we'll see, the real interest rate. So understanding the fundamentals behind what determines saving and investment is an important part of the story. So let's look at, we can look at these things in turn. So again, we have saving is just equal to y minus c minus g. And so the question is, what determines or what drives those three things, those three elements? And so if we want to flip to the notebook, oops, there we go. So if we flip to the notebook, again, the point here is that we have saving is equal to y minus c minus g. So the question is, what determines each of these three pieces? Okay? And so we can tell a story around what determines these things. So first of all, if we look at, if we look at savings, again, if we look at income, we've already looked at that question in Chapter 3. What determines income or production? Well, the production function itself, as well as the inputs into production, capital and labor. So if you recall the story, capital and labor and technology are excuse me, exogenous or fixed in the long run. So at the end of the day, what that means is that output is just some predetermined number. It's just fixed. It falls from the sky. Okay. Again, fixed, it doesn't mean fixed in the sense that it can never change. Fixed here means that it's dependent upon other things that are predetermined and exogenous to the model. So we're not trying to understand or explain output or production in the long run. It's determined, it's predetermined by these other factors. The second piece is consumption. And so there's going to be two main pieces, or three rather, main pieces to this, which I'll go into more in depth in later chapters. But essentially with consumption, you have autonomous consumption is going to be driving consumption, disposable income, and interest rate factors. Okay. And then government spending, that's pretty straightforward. That's determined by fiscal policy. Okay. So if we go back to these things, you can see we have these factors here. So as I talked about before, I just want to make sure that I'm not, okay. So if we go back to these pieces here, we have our consumption function. There's the first piece that I talked about, autonomous consumption. The idea simply is that that's the amount of spending that goes on, consumption spending that goes on that's independent of people's income or independent of the interest rate, as it turns out. So we can think of this as consumption spending driven by wealth or other factors. And then the other part of this is consumption is going to be driven by changes in disposable income and also changes in the real interest rate. So this is the general form. This thing here is just a general form which says consumption is driven by autonomous consumption, and this function here, which is dependent upon disposable income and the real interest rate. Now, why is this important? The fundamental idea is that if disposable income goes up, people have more money in their pockets, they're going to buy more consumption goods. So you would expect a positive relationship between disposable income and consumption. However, the opportunity cost of consumption is the real interest rate. If real interest rates rise, the return on saving goes up, and that discourages consumption. So you would expect an inverse relationship between the real interest rate and consumption. So consumption is also going to be negatively related to the real interest rate in terms of representing the opportunity cost to consume. Okay. The second piece of savings, so we've looked at income, that's driven by technology and inputs. We've looked at consumption, that's driven by autonomous consumption, disposable income, and the opportunity cost of consuming, which is the real interest rate. And then the third piece, government spending, as I said before, that's driven by exogenous political factors which determine fiscal policy, determine tax policy and government spending policy. Okay. So the question, again, fundamentally is thinking about all of these pieces and how we put them together. Okay. We have savings is equal to y minus c minus g. We know that consumption is driven by this sort of convoluted equation here, okay, with the underlying factors of autonomous spending, disposable income, and real interest rates. Fiscal policy is determined by these exogenous factors, and production or income is also exogenous, and it just drops from the sky. So these are just numbers that are given, okay? So that's on the savings side. And then the flip side of that is the investment curve. So that investment curve is right here. So our investment curve is composed of two components. The first is this I bar, which that we refer to as autonomous investment. So this is analogous to the consumption side. It's just investment by firms who, which is decoupled or independent of interest rate effects, okay? So fundamentally, the idea is that, well, if firms think that the economy is going to be doing really well in the future, even if interest rates are unchanged, they might be willing to borrow more to invest in new capital equipment because the returns on that capital equipment is going to be higher. And so autonomous investment might rise. And then the second piece of this investment story is investment that depends upon the real interest rate. So we think about the real interest rate as being the opportunity cost of investing. If you're a company and you have to invest and buy capital equipment, that's usually a pretty expensive proposition. We're talking about millions and millions and sometimes billions of dollars spread out over potentially years. And so inevitably, most firms finance their investment in capital acquisitions by borrowing. And so not surprisingly, as the cost of borrowing rises, it's going to be more expensive to borrow, and therefore firms are going to want to borrow less and therefore invest less. So you would expect it, on the investment side, the real interest rate to be inversely or negatively related to investment. Okay. So the question is, again, how do we put all of these pieces together? Well, let's focus on saving, okay? Again, keep in mind that saving and investment are two separate and distinct things. Savings go on through household saving behavior, and if we're lucky, government saving behavior as well. But as it turns out, government can actually be a net draw on savings, as we've seen in previous videos. The flip side of that, of course, is this financial intermediation story. Savings gets channeled through financial markets to those who want to borrow them, i.e. the firms. And so that's where savings and investment are distinct, but they're related. So on the savings side, as we talked about, savings is just income minus consumption minus government spending. We know what determines income, right? We talked about Y bar. That's capital, labor, and technology, all presumed to be fixed or predetermined. There's consumption, right? We have the two pieces there, the autonomous consumption part, and then we have this other complicated sort of general function which relates disposable income and the real interest rate to consumption as well. And incidentally, this should be a plus sign right there. Sorry about that. And then the last piece we have is government spending. So if you put all of these things together, everything in this savings expression has a bar over it except the real interest rate. Everything is predetermined. So savings is completely predetermined except for variation in the real interest rate. Variation in the real interest rate impacts households' decisions to consume versus save. So a higher real interest rate means households consume less and save more, and therefore the total amount of savings in the economy is going to be higher. And so the punchline then is that saving in the economy is going to be directly related to the real interest rate, and that's going to be a positive relationship. In other words, as R goes up, the opportunity cost to consume is going to be higher. That means less consumption and more saving. Okay, so the quantity of saving in the economy is going to go higher as the real interest rate rises and vice versa. So what that means is that our saving function is going to be upward sloping. And I think if I flip back to these slides, oops, we have an example of this, so we can see an example of this right here. So there's our saving curve. Again, this is upward sloping. And so the idea is as the real interest rate rises, the incentive for households to save rather than consume goes up. And so there's more saving generated in the economy overall. Okay, so now if we go back to our investment function, oops, let's see, it's up here. Okay. If we go back to our investment function, again, the idea is that investment is going to be determined by autonomous investment and interest rate. And so the real interest rate in this case represents the opportunity cost of investing. So as the real interest rate goes up, you would expect investment to go down and vice versa. Okay. And so as a result of that, again, if we look at this investment curve, that's going to be downward sloping. Higher real interest rate, it's more expensive to invest, less investment, and vice versa. Okay, so as I said, we have these two pieces of the puzzle together, saving and investment. So at the end of the day, we're going to be channeling extra saving through financial markets, and in equilibrium, that's going to be exactly identical to what firms want to borrow on the back end, okay? And it turns out that that understanding, that intuition is a goods market equilibrium, okay? So what that means is that the amount of saving in the economy is exactly equal to investment, and that's going to be a goods market equilibrium. If it's not, then the interest rate is going to adjust, as we'll see, in order to ensure that that goods market equilibrium exists. Okay. So what does this goods market equilibrium look like? Well, again, if we start off with this fundamental condition here, output is equal to C plus I plus G plus net X. So that's that national income accounting identity. If we assume, again, we're in a closed economy right now, so we're assuming that net exports is equal to 0. If we rearrange this, then you get Y minus C minus G is equal to investment, or Y minus C minus G is equal to savings, okay? So this is our goods market equilibrium. Total production is exactly equal to what households, firms, and government want to buy, no less and no more. The analogy, the flip side of that, is that saving in a closed economy is exactly equal to investment. So the amount of savings generated is exactly equal to what domestic firms want to borrow in that equilibrium. So those two things are equivalent. So that's why we call this our goods market equilibrium condition. Now note, this is the goods market equilibrium condition for a closed economy. Now when we look at later on a small open economy and we allow trade flows, this is not going to apply as a goods market equilibrium condition because we have to deal with the net exports and the net capital flows. So keep that in mind. Okay, so as I said, when we put these pieces together, our goods market equilibrium is where saving intersects investment, right? So at that point, right here, where savings intersects investment, at this point right here, where savings intersects investment, that's our good market equilibrium. Output is equal to consumption plus investment plus government spending for the exact reasons that we just talked about. At that goods market equilibrium, the equilibrium real interest rate is R star that we're assuming here. And at that, again, at that equilibrium, saving is exactly equal to investment. So that's our goods market equilibrium in this framework. Okay, so what I want to do now oops. Okay. So what I want to do now is go through a numerical example to understand this process a little bit more. So as I remember when I talked about before, these things are basically predetermined, most of these things. So there's our production function with inputs and technology that just spits out this level of income 1200. Here's an example of a consumption function, right? So we have autonomous consumption. We have this thing that depends upon disposable income. And then we have this other portion here, which is the opportunity cost to consuming. You'll notice that there's a negative sign there, meaning that as the interest rate rises, consumption falls and vice versa. And there's our specified fiscal policy. So if we plug all of this stuff into our savings function, again, what we're doing here is actually deriving a savings function. So it's just y minus e minus g. That's 1200 minus this expression. This whole expression here in blue that you see, that's the consumption function. And we just plugged all those numbers in there. And then don't forget about g, which is tacked on at the end there, right? So y minus c minus g. Now, it turns out, I'm not going to go through the steps of the math, but you should do this, is solve for this. And when you do, when you solve for this, you're going to get something that looks like this. Savings is equal to 50 plus 10R. Now, you'll notice that we have a positive sign there. Now, one of the fundamental mistakes that I see students do time and time again is that this minus sign there eventually is going to be multiplied by that minus sign there to have a positive. So it's important to remember when you're doing these calculations in this consumption function that you do the math carefully, because at the end of the day, you should end up with something that's a positive number there, or a positive slope, okay? So when you solve for that savings function, that's what you get. Now, how do we use this? Well, here's our savings function. Suppose we have an investment function that looks like this, okay? When we put those two together, our goods market equilibrium is going to be where savings is equal to investment, when those two things intersect, right? Again, saving and investment, those are separate entities, but they're equivalent, they're equal to each other numerically in a goods market equilibrium. So essentially what we're doing is forcing a goods market equilibrium here. So the way that we solve for this is we simply set savings equal to investment and solve. So if we do a couple quick steps of math, it's pretty easy to see that the interest rate in equilibrium is going to be 12. So that's right there. And we can find out what our goods market equilibrium level of investment and savings are simply by plugging that back into either one of these savings or investment equations. So it's pretty easy to see that this equilibrium, if we plug it in with the savings function, is going to be 170. And you should get the exact same answer if you plug it into your investment function there. So that's what our equilibrium in this goods market equilibrium setup looks like. And one other thing is we can calculate, say, private and public saving. Remember those things? So public saving is just the difference between taxes and government spending. So in this example, if you look back, both taxes and government spending are identical. So that means we have neither a budget deficit or a budget surplus. In this case, public saving, or government saving rather, is equal to 0. That implies a balanced budget. Okay? So it's important to remember that that represents neither a net draw or a net surplus into national savings. Now, what we know from fact is that the U.S. government over a long period of time, more recently, though, has been running large deficits. So that represents a net draw on national savings, if that's negative. And then, excuse me, and then private saving is y minus c minus t. And again, I'll leave you to solve for this. But if you go back to the savings and investment functions in equilibrium, we know that our equilibrium interest rate is equal to 12, so we plug that in there, and we solve for public saving, and it turns out at that interest rate, private saving, at that interest rate, private saving is equal to 170. And you'll note also that when we add, in this case, government and private saving together, it equals 170, which is exactly what we got in the previous example. Okay, so I'm going to go very quickly through a couple more examples. So we've looked at the equilibrium, the goods market equilibrium, and looked at both the visual and the numerical way to solve for it. So the question is, what happens if some of these things change? We've seen the factors that affect saving and also seen what goes into investment, so we can look at those in turn. Now, suppose that we have a decline in autonomous consumption. So maybe wealth goes down or something like that. So that can influence households to buy less, even if their incomes remain the same. So if autonomous consumption goes down, then overall consumption for households is going to decline. And so if overall consumption goes down, that means that y minus c minus g is going to go up, okay? And so in other words, saving is going to go up. If households are buying less, then the flip side of that is that they must be saving more. And so at any given interest rate, that's going to result in a shift to the right of this saving function. The equilibrium result is that equilibrium investment and saving is going to go up. And the real interest rate is going to go down. So this helps us answer one question for what drives real interest rates in the long run. Well, you can see that if consumption falls in the long run, that's going to push real interest rates lower. Okay. So here's another example. This involves fiscal policy. So again, fiscal policy is one of the other things that affects national saving. So suppose we have a decrease in taxes. Now keep in mind that a decrease in taxes is going to affect both private saving and public saving, okay? But the magnitude of those effects are going to be different between the two. So the easier way to think about this is to think about, well, overall, what happens to national savings? And so if we think about the decline in taxes, that means that people are going to have more money in their pocket. So disposable income is going to go up. If disposable income goes up, that means that people are going to want to buy more things and consumption is going to rise. And when consumption goes up, what happens to national savings? Well, we have the minus sign right there. So when consumption goes up, saving is going to go down. And so what this means is that at any given interest rate, the amount of saving in the economy is going to decline. The quantity of saving available is going to go down domestically. And so we get this shift to the left of our savings function. That results in an equilibrium, a higher equilibrium real interest rate. And as a result, less saving and investment in the economy. Now, this is an important point, an important lesson to understand. Here, we had a fiscal policy effect which resulted in a higher long-run equilibrium real interest rate, right? Underlying this, what happened? We cut taxes. If we cut taxes holding spending constant, that's going to create deficits. So, that's going to create a surplus, rather. And so the net effect of that is, scratch that. So when we cut taxes, I'm getting flustered here, bear with me. When we cut taxes, that's going to generate more of a deficit, right? So less revenue coming in if we're assuming the same amount of spending. So you're going to have higher deficits being generated. And overall, the effect is to negatively impact national savings, okay? And so the punchline again here is that with higher real interest rates, the cost of borrowing for firms is going to be higher in the long run. That's going to discourage borrowing and investment in new capital equipment. And that in and of itself can be lead to declines in long-run productivity and hence economic growth as a result. And so this is a result of what's referred to as crowding out of fiscal policy. So we have a fiscal policy effect which generates budget deficits, the result of which is that we have declines in saving in the long term. That drives real interest rates higher. And as a result, you get this decline right there in equilibrium saving and investment. So fiscal policy, in some sense, crowds out private investment and lowers the equilibrium level of investment. And so, as I said, that can be problematic for reasons that I just mentioned. And so finally, we have one more example here. If we have a decline in autonomous investment, this can be for a variety of reasons, but to give you one example, a decline in business optimism or a decline in business conditions that might prompt firms to want to invest less in capital and equipment and those kinds of things. And so at any given interest rate, the amount of investment in the economy is going to be lower. The amount of investment demanded is going to be lower. And so what that's going to do is result in a shift to the left of this investment function. And when this investment function shifts, the equilibrium effect is to lower the real interest rate. And of course, with a lower real interest rate, that discourages households from saving as much. And so we get this new lower equilibrium level of both investment and saving. And so we can see here that when we put these two pieces together, both saving and investment are an important part of thinking about what drives long-run real interest rate, okay? And so we've seen fiscal policy can play an effect. Other types of any type of consumption behavior also drives national savings and can impact the real interest rate. And so fundamentally, the important part to understand and think about, as we talked about before, let me see if I can get this right. No, wrong slide, is this point here. Again, with this slide, remember, when we think about savings, everything is predetermined except for that real interest rate. So savings is that upward sloping function. Likewise, investment is negatively related to the real interest rate. Saving and investment are separate entities, but in a goods market equilibrium, they're numerically equivalent, and that's where they cross. So that's what our goods market equilibrium is. And that goods market equilibrium determines the real interest rate. If we're not at that interest rate which savings and investment cross, then natural market forces are going to move in order to ensure that that goods market equilibrium level of output, excuse me, that level of output and savings and investment and all that kind of stuff is achieved. And so that's the closed economy model. As I said, in later video, we're going to look at relaxing this assumption, but we're going to look at it from the flip side of, well, let's assume we can't control the real interest rate at all and look at capital flows and look at an open economy framework. That's for the next video. Thank you.